Most people assume the ultimate objective of industrial safety is the total elimination of all workplace hazards. They want a guarantee of zero harm. But engineering a completely risk-free environment is a physical impossibility. To achieve it, you would have to halt modern production, ground every logistics fleet, and shut down heavy infrastructure. The core reality of safety engineering is much more pragmatic. The objective is the calculated mitigation of unreasonable hazards. To determine if a hazard is reasonable, engineers apply a strict dual filter test. First, is a solution physically feasible, given the constraints? Second, is it economically feasible without destroying the operation's viability? Because risk cannot be zeroed out, it must be managed as a rigid, quantifiable production variable. This creates a massive regulatory challenge. A federal oversight agency needs an objective way to compare the inherent danger of a quiet accounting firm to the hazards of an active metal fabrication plant. Looking at raw accident counts is statistically useless. 10 injuries at a massive auto plant represent a totally different risk profile than 10 injuries at a 5-person machine shop. This animated bar chart shows non-fatal injury incidence rates across different sectors. Normalizing the data reveals the stark variance between low-risk environments like finance and high-risk manufacturing. This standardized baseline normalizes the factory floor's chaos, creating a clean metric that levels the playing field. To understand how these national benchmarks are generated, we have to look at the exact mathematical calculus used at the individual facility level. Federal regulators require every facility to use a standardized master formula to calculate their incidence rates. This equation divides total injuries and illnesses by total hours worked multiplied by 200,000. That multiplier represents a specific model: 100 workers, 40 hours a week, 50 weeks a year. It acts as a constant, projecting distinct accident data onto a standard 100-employee year. The denominator, the actual cumulative hours worked by all employees during the study period, anchors that projection to reality. The math itself is straightforward algebra. The operational complexity lies in deciding which specific incidents legally qualify to be counted in the numerator. Before any numbers are calculated, raw incidents from the factory floor must pass through a strict, high-stakes legal triage. The first step in this triage is establishing the strict legal boundary between non-recordable first aid and recordable medical treatment. If a worker drops a loaded pallet on their foot, but hospital x-rays are negative, and they only receive whirlpool therapy, the law categorizes that intervention strictly as first aid. As a result, the incident is filtered out. The facility's incident numerator does not increase, and the official rate remains unaffected. However, if a flying chip enters a machinist's eye and requires physical extraction by medical personnel, that crosses the threshold. It officially qualifies as medical treatment and enters the calculation. A secondary filter separates acute, immediate hazards, classified as safety incidents, from chronic exposures, which are classified as health hazards. This macro-level close-up illustrates repetitive mechanical stress on a human joint. Conditions like carpal tunnel syndrome rely on the invisible accumulation of stress over time. Chronic illnesses are notoriously difficult to track and prove compared to a sudden traumatic safety incident. Yet, they carry the exact same regulatory weight. Only the incidents that survive this rigorous medical and legal filtration process are officially coded into a facility's permanent regulatory ledger. Consider a data model for a metal fabrication plant with 250 employees, compiling its annual hazard records. This log is the OSHA Form 300, the official ledger for these records. Notice how the raw data from filtered incidents, like the extracted eye chip and the carpal tunnel diagnosis, are officially categorized into columns designating restricted duty or days away from work. This data generates specific benchmarks, starting with the DAF-WE-I rate, days away from work injury and illness, tracking severe cases where a worker missed subsequent days. With 500,000 total hours and 2 qualifying cases, the math yields a strict DAF-WE rate of 0.8. Federal inspectors use a broader, critical benchmark called the DART rate, days away, restricted, or transferred. Adding restricted duty cases, such as a dock worker temporarily moved to an office job, drives this specific plant's DART rate up to 1.2. By deliberate regulatory policy, fatalities are excluded from these standard formulas. This ensures that rare, extreme events do not mathematically skew the general operational benchmarks. These derived decimal points are the exact numerical triggers that dictate federal audits and directly impact corporate economics. At this stage, the data moves from regulatory compliance into pure operational economics. Insurance companies apply a workers' compensation experience rating modifier to determine coverage costs. A facility's historical incidence rates, specifically metrics like the DART score, dictate this modifier, which acts as a direct multiplier on base insurance premiums. This iceberg model illustrates the financial reality. The OSHA metrics and the workers' compensation modifier sit visibly above the waterline. Poor metrics inflate these direct costs, drawing the ire of corporate executives. Focusing solely on these direct insurance premiums represents a major executive blind spot. The visible costs are painful, but they are only the tip of the economic damage. Every single recorded incident generates massive, uninsurable operational friction. Beneath the surface lies a massive structure of hidden cost categories. The operation pays wages to uninjured workers who stop to assist, absorbing the cost of lost supervisory time. Secondary impacts follow, like extra overtime wages to catch up. There's also a long-term drag caused by human capital turnover. A replacement worker requires a costly learning curve to reach the previous baseline efficiency. These hidden costs bypass insurance protections entirely and pull directly from the operation's profit margins. Rigorous safety data classification and hazard optimization are vital, line function feedback loops required to protect the economic survival of the operation.